Hello, 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 hello. We are back.
We are back on track.
We are back on track, time-wise too, or ish almost. But close enough. Close enough. I have the great honor to introduce someone who is not part of our regular community, a new face. Her name is Lisi. She works at They Do. She's a veteran in all things content management system. And please be nice to her, include her, make her feel welcome, especially now as she joins us on stage. She's come all the way from Austria, and we are ready to leave the stage to her, not before reminding you to send in your questions, as usual. So we get to forward them at the end of the talk. Thank you, Lisi. Take it away.
Thank you. Hi, everyone. I'm Lisi. I'm really excited to be here. I'm not a Neos developer, but I worked on a headless CMS the past 4 years as a front-end architect. And this talk is a little bit about the learnings I had working on this, mainly on the front-end side of this headless CMS. And yeah, it was a very fast-growing scale-up, so it was growing in an immense speed. When I joined, it was about around 10 people. When I left a few weeks ago, it was over 300 people. So this talk really also focuses on that side of building a fast-growing CMS. And as an architect, as a front-end architect, I often get the question, what does a front-end architect even do? And it's not that easy to explain, but I will try to explain to you what a front-end architect actually does. So in reality, there are many, many different kind of architects you can have. You can have business architects that really focus on more the strategic side of the business and architecting in that area. You can have very technology developer-focused architects. That's normally where the software or the front-end architect lies. But you can also have architects on the vendor side. So the solution architect, I think, is a very common term. And also on the operations-oriented side, on the network side, these kind of architects that are really close to the operational side of a system. And there's a great blog post that describes in more detail and has a lot of interviews with people that have these architect roles. But here you can see an example calendar of what an architect might does. They give a lot of feedback. They have a lot of they do a lot of discovery around problems. On the front-end side, for example, you do discovery on performance, maybe on accessibility, on general issues on the front-end side of the system. You will have a lot of planning and a lot of team meetings. You will meet with different teams to make kind of more long-term plans. And generally, you're very involved with the whole organization. So if you have to define a person who would have a kind of architect role, generally they have really good communication skills. So they can talk to different teams, they can talk to different stakeholders. They also know systems quite well, so they know the one system, maybe the front-end side of the system, the front-end architect knows well, but maybe also multiple systems with the whole organization. They are quite informed about technology, so often they need to help make technological choices, and they will review different options and try to make a good decision for something that needs to be maintained over a long time. They care a lot about usability, especially a front-end architect cares a lot about usability, about what the actual end product is. If it's like very slow or if it's really inaccessible, they look a lot at like the overall aspect of an application, whereas a team looks more at one specific area maybe of an application. And they provide a lot of high-level guidance, so meeting with different teams, meeting with the front-end developers, meeting with maybe the CTOs or certain stakeholders or certain clients to help make decisions that influence the business over a longer time. And yeah, generally they have really high performance, and they also have some good judgment that also consider the business and consider more than just like the framework, for example. So that's kind of what I discovered in the past 4 years, what architects do. So it varies in many different ways. But when I worked on the CMS the past 4 years, I worked on very fast scaling code bases, and I say that's very similar when you try to create a zoo. In the beginning, you have a nice empty space, there's some trees, there's a lot of free area, and you can be really creative with what you create. So you start to bring in some goats, some sheep, maybe a llama. You have a nice little petting zoo. There's 1 or 2 people who feed the animals and to take care that they're all doing well. And then the zoo is doing really well, so you decide, yeah, let's bring in some more exotic animals. Maybe we get a panda or like a camel, and so we can attract more people to our zoo. That's really so nice. And then as you get more animals and more caretakers, it's starting to get a little bit more chaotic. And you just say, well, this person takes care more of the exotic animals, and the other one takes care more of the sheep and the goats. And everyone gets like a little bit of an area in that growing zoo. And then some investors come along and they're like, wow, this is a great zoo. Let's make it like a really big, professional, huge zoo. And they give you a lot of money to grow your zoo and to properly build your zoo. And suddenly, in a very fast way, you get a lot of caretakers, you get a lot of new animals, you get a lot of bigger areas, you expand your zoo. And it starts to get really chaotic. So this is often then where you start maybe getting an architect who's like, well, maybe we should try to bring some order to this chaos and see like how we can keep some consistency across the whole zoo. And an architect normally you will have with maybe 50 to 100 engineers, you will have 1 architect. So there aren't that many architects actually in like big companies, but you do need them to make some order. And what the architect does is that often they bring in some certain rules, like maybe they say, well, we can only have a certain vegetation type in a certain area. We have like the African animals, and we have the birds, and then we have like 2 or 3 caretakers per area of the zoo. And that's what a lot of architects do. So they try to constrain how things are built, to bring some more order to like this very fast growing chaos that often involves with scaling very fast. So we go from like not a lot of rules to maybe some more rules of like how we expand also the zoo and how we build certain parts of the zoo that are clearly defined. So that's also where technical debt comes from. So the first few years, and I've also seen it working on the prototype of the CMS, you have to take on a lot of debt as you're growing, because you need to come to a point where the customers actually want to use your CMS, and you can only do that by iterating very fast. There's often no time to write tests. There's no time to like properly isolate everything. So you're fine with taking on technical debt to find a product market fit, to find some place in this market where your CMS really fits into and where the customer is happy with using it. And then as you find this product market fit after a few years, you want to scale and you want to become more stable. So the customers are paying for your product, they're using this product, and they don't want it to have dozens of bugs and not work, and they want to publish on time and make sure that everything works. So when you have found this product market fit, you start working on reducing this debt. And the more you scale, the bigger and the more customers you have, the more effort you have to spend on reducing this technical debt. And the more you have to invest also time and resources in working on migrations or adding testing or whatever it is where your technical debt lies. And technical debt, the reasons for technical debt that I've seen are not that people don't care, developers don't care, but there's a lot of like very simple reasons why you get more technical debt. The one that we've seen now is that things grow very fast, so there's not enough time. But there's also other reasons, like you have skill gaps in a team where you bring in maybe a junior developer, or you bring in a developer that has developed in a different language, in different systems, and they don't know all yet that you have in your system. So they will try to work with the system, but maybe through the skill gaps, they produce some technical debt. You often have technical debt in code that keeps breaking, so especially if you have really old code that's very hard to extend, a lot of spaghetti code that's very mingled, and then some developers come in and they try to develop this feature. They don't want to do a bad job, but developing in that area is very, very difficult. So there the technical debt keeps growing just because of the quality that kind of code has. The tight deadlines, the fast growth are one of the biggest reasons I've seen for technical debt. So you don't have the time to write a test, you don't have the time to, you don't have someone who helps you test it, so you have to test everything yourself. Maybe you don't have a lot of people who do code review with you. There's a lot of reasons why tight deadlines make technical debt. Then the missing standards, that's also where the architect often comes in, who helps the developers define standards, who goes to the teams and says, well, should we do this or should we do that? And actually defines a common language across different teams and across different developers. Old libraries are often a reason for technical debt. They become increasingly hard to work with. And then, as we've also heard before, often you have some unused feature, you have some old code that you really want to remove because it's not actually needed or used anymore, and you want to get rid of. So then we're like, okay, now we really want to tackle this technical debt. You got the buy-in from your product managers, from your team leads, whatever it is that you need to get the buy-in from. And you start rewriting the code. And rewriting the code feels really good. So we rewrite code because actually it's really fun to rewrite code. It feels good to make it better, to make it properly, to remove all the bad bugs that code has. And by rewriting code, often we learn how it works. So that goes in hand with this skill gap and not really understanding what's happening there. When we rewrite the code, we get really a better understanding of why maybe also the old code was written that way and why the system is not working anymore or is working in the way it is. Most of the reasons is like fixing some breaking behavior, fixing some bugs, fixing some broken feature. There we rewrite a lot of code. Often when you migrate to a new library, to a new framework, you rewrite a lot of code, you rewrite a lot of areas of an application. And also, of course, with changing requirements. So something that was important 2 years ago, it might not be important today. So you decide, okay, now we're going to rewrite that area and make this feature in a completely different way. And that's also what I've seen when we migrated from Vue 1 to Vue 2. We actually rewrote a lot of the code instead of trying to bring it to this new framework. So that's a little bit the beginning to why front-end architecture is important. The technical depth and rewriting the code, where the architect really helps the teams to do that. And that's kind of what we tackled already a little bit in this talk. So now we will look at some different areas. We will look a little bit at visual architecture, at code structure on front-end sides, on the developer experience, also the tech stack and tooling, and a little bit about migrations, and then also a little bit about the production processes. So when we work on the front-end side of systems, what's really important is also the visual architecture. So front-end system, generally, they're very close to design. Front-end developers, they're very design close. They think about colors, they think about interactions, they think about how something behaves. So the visual side of a front-end system is quite important. And the smallest part of that, this connection to design, are design tokens. So design tokens are our basic building blocks of how a brand looks like. So it's the definition of the color, but not just the 5 main colors, but also all of the background colors, all of the border colors, all of the text colors, and how that color behaves when you hover it, when you focus it. So these you can all define through design tokens. And they're really important because they help you map your brand and what all the designers do to actual technical values that you can reference in all of your different projects that you have and that need to use this design. And yeah, the most important ones are of course, color. I have an example here of Shopify's token system that's called Polaris. And there you can see some things that are really important to define. You have width, you have motion, you have font sizes, of course, you have the colors, but you also have things like borders and breakpoints and spacing and text sizes that are important to discuss and to define. Because if you don't define them, you will end up at some point with a lot of inconsistencies in the design and in your apps and in your components. And on the technical side, you can see a lot of these definitions, for example, in Tailwind. The Tailwind config is a good example of having actually each value defined for each font size and for each color. But most more extended design token definitions are often written in TypeScript and are more dynamically created through a kind of build step where you then can export and reference all those variables based on actual typing of all the design tokens that you use in your application. So the biggest issues I've seen is really with missing definitions around hover states, around spacing. So in many apps, there's often inconsistent spacing because they don't have these tokens, they cannot use these tokens, but also around text sizes, like which text size does a heading have and which text size does a button have. So a lot of these missing definitions then end up in visual inconsistent components. So that's our constraint number one that the architect will look at. He wants to define and coordinate all design-related values and changes together with the teams and also the designers. The next step to that, after you have your tokens, you already know all your colors and your sizes and your spacing. At some point, you will start working on a design system. You will start defining the actual components that are used within your application or within your multiple applications. And instead of having 10 or 20 different variations of buttons, you have one button that's really well defined with all the outline colors, with all the hover colors, with all the focus colors, and with all the variations of a ghost button or outline button. And that's a really important part of front-end architecture, is having these design systems and having people working on these design systems and creating these kind of lower-level core components together with the designers. And it takes a lot of time to build a design system. This is an example of Atlassian's design system, where you see a lot of important parts of how a design system should be built. So you should have actually some interactive components there that you can click through and use. You need to have some code usage. But you should also have maybe a change log for the component. How is this component changing over time? And which components might be deprecated and shouldn't be used anymore? So a good design system is also really properly documented and has a lot of work on the documentations. And in my current company with around 12 developers, we have 1 or 2 people who work almost full-time on this design system. And generally, it's a good idea at some point to get a developer working on it full-time, because otherwise it will get deprioritized over like shorter-term projects. And I've also seen that, like, if there's no one responsible to maintain the design system, it will get very hard to keep the quality and especially documentation active of that design system. And the bigger the companies get, of course, and the code bases and the projects get, the more people you will have working on these design systems. And in monorepos, how I've worked with it is mostly that you have some kind of separate package. You can have that with Yarn workspaces, for example, where the design system lives a little bit more isolated, more separate. And it can be open source or it can be closed source. I worked more on open source packages, but they're always more isolated and they can be installed and imported. They don't live within your normal application components. So that's the second constraint, defining all the base components and coordinating with the designers around how these components work and all the variations of these components. And lastly, that's for like really if you grow quite large, is this design documentation. And it's even further around the design system. The design system has a lot of components and color definitions and some documentation. But a proper design documentation goes further. It actually documents really well how do you develop certain models, how to make things accessible, what kind of the rules are in your design to build proper interfaces. and things also that you do not want to do within your brand in terms of interactions, accessibility, all these kinds of things. So that's kind of some really important parts of the visual architecture, where the architect will often be involved in going from A to B and figuring out how to do the technical part of that side and how to work with the different teams. So the design team and the front-end development team and maybe also the back-end development team, they're on the same page when it comes to these design definitions. The next part is code structure. So in front-end code bases and large code bases, of course, we also work with a lot of code and not just design. As I said before, that the architects starts to add some more rules, they start to add some more structure, and that can be in many different ways. One of the first ways is, of course, commit messages, so having some clear definition of how commit messages should be written. Most companies would use semantic commit, and the advantage of that is that you can really fast generate automated change logs of like which ticket is related to that in your Jira or in your Linear. You can directly link a code change to these different software development systems. That's quite important to have a kind of clear definition for your commit messages, but also for how the code is written. So really good setups with ESLint, with Prettier, how the formatting happens, which ESLint rules you kind of use. So ESLint rules, you often need to discuss which are the do's and the don'ts, and there's many, many rules you can activate. But how the ESLint is configured also depends on your teams, and you need to talk to the different developers and have a kind of communication culture around how the code should be written across the company. And yeah, documentation, of course. How do you show that things get deprecated? How do you actually document the code? Do you even allow commenting code? Like in some projects, it's not allowed to comment code. But these documentation definitions are quite important. And the formatting, of course, in ESLint is also very important, where you say, well, you cannot commit code if it's not properly formatted, or if it's against certain ESLint rules, you cannot commit to this code base and actually add new code. So that's very important that the more developers you get, because the more developers you have, the more messy the code bases also get. So that's the constraint number 3, is defining how code and documentation should be written. And when we think about front-end code, we work on a lot of components. So front-end developers, they write components all day long. They write the same component 20 times, and they cannot write another list component, for example. But what happens when we create components mostly is that you would have a team, and they start working on an area. They start creating some components and some more components to be able to ship this new feature they need. They need to add all these new components that might not exist yet. And then you have maybe a second team, and they also have a different area with like maybe an onboarding area or payments area, and that needs a total different set of components. So they also start developing their own kind of components. And then the designer comes along, which is maybe shared between the two teams, and he says, yeah, now in this second team, we will use this component that we already have in this other area of the application. And we can just reuse that. It's very easy. So the developer of the second team says, well, okay, I will extend this components, and instead of like copy and pasting it to my area, I will make it like globally flexible so we can use it anywhere in the application. And that's where a lot of coupling happens. And these components, they're quite common in these code bases. And they have a lot of these if-else statements. A lot of like, if this component is here, do this. And if this component is there, do that. And that really goes a little bit against the single responsibility principle, where a component should always have a single responsibility and do that really well. And the biggest mistake I've also seen in these code bases is on really large components that mix business logic, so the logic that's kind of responsible for fetching your data, processing your data, calculating something, and doing some core operations, mixed with the UI, with the view logic. So managing how the component is presented, what interaction it has, what's it rendering or not rendering. And when we develop components, it's really, really important to think about what is actually business logic and what's our UI logic. And when we have a component, we have normally a view part, that's your HTML. You have a reactivity part, that's like clicking or hovering or dragging or whatever kind of user interaction you have. And you have some kind of business logic that really doesn't depend on the view or on the reactivity. So the easier and the more maintainable components are components that really focus on this view part and on this UI kind of logic. And a simple React view component, just really focuses on returning some HTML based on some kind of props it's passed down. So it doesn't do any calculations, it doesn't fetch any data, it's just purely returning some kind of HTML. And then you have these kind of renderless components that do not have any view. So that's in React, it's mostly done with hooks. In Vue, it's done with composables. But these components basically do not have any HTML. They're just there to fetch some data or to process some data or to calculate some kind of state. Often they do maybe some state calculations based on some response from somewhere. But they do not need to know about the HTML. They're just there to do some kind of business thing. And then we can connect the two, which is with a pattern called the container presentational pattern. And the container presentational pattern basically adds the two together. So it takes the view and it takes the business, and then it makes a container around it to connect the two. So now we have a container here, for example, that's for the rendering the Star Wars people. It imports our business logic to do all the business things, and then below it would use the view component that we had before. And then you could use different containers in different areas of your applications that are separate from each other. Instead of doing all these if-else statements, you use these different containers, and you're okay with some kind of duplication in order to allow these components to grow over time and to also evolve independently from each other. So instead of this, we try to decouple it and make their own containers and their own kind of logic for that kind of application area. And the only kind of components we share are often this view only or this design system core components we have in our system. So that's our fourth constraint, is defining the internal component structure and also how your components are named and how they're structured internally and how the process is of connecting the business logic with the UI logic. Then, of course, it's important how the code base is organized. Normally, this is already done when you start on a project, but of course, there are some main ways of organizing your project. You have the monolith where everything is together. You will see this often with like very crude prototypes where that can be nice because it's very fast and very simple to set up and use everything, but it's not very scalable to have a monolith. Then the second one is a monorepo. That's what I work on currently. So you have one repository that has the backend, that has the front end. It also has the business logic in a separate package. It has the E2E testing. It has basically all of the things that you need to run your application. And then the third one is the multi-repo, where you have one repository for each of your projects. And that's what I worked on before when I was working on the CMS. We had a multi-repo setup, and that is very nice because it gives a lot of independence to each team. So the front-end team can build their own processes separate from the back-end team, and you can build like really separate kind of logic and processes based on kind of which part you're working on. The disadvantage is that you also start to get a lot of inconsistencies in multi-repo setups, and then you need to go back and define how to keep some consistency around how the backend and how the front-end developers work together, for example. So defining how these different projects are linked together and how these teams collaborate with each other is also a very important part for the whole organization. So if you have a mono repo structure, you will be a lot closer to actually the backend work that's happening or the testing work that's happening. If you have a multi-repo structure, you will be a lot more independent, but you will not see so much of what actually maybe the QA engineers or the backend developers are actually doing. And then if you go down, it goes down to the folder structure. So as your application grows, it's really important to standardize a little bit where and how you create your components and your stores and all these different kind of front-end parts. And I will just quickly show you some examples, but that really also, the folder structure really depends on your project, and there's not one true solution of how your folders should be structured. So one example is a hexagon architecture that you can also look up, there's a link. But that really focuses on creating adapters of the different parts of an application. So in the core of the hexagon, you have the core app. That's a lot of the business logic that you have around your application. And then you start adding different adapters. So you add one adapter for your API, you add one adapter for your database, you add an adapter for your view, so maybe that's a view app, or you add another adapter for your React app, or your React Native, or your mobile app. And this architecture, there's a link here that you can look at. It really focuses on creating these interchangeable adapters that can also be removed over time. So maybe at some point you don't want to have a React app anymore, you want to have a Vue app instead. And then through this adapter kind of architecture, you will be able to change certain things. And that's a very common adapter plugin principle, where one of the simplest adapters you can have is like a HTTP adapter that can make a GET and a POST request. And on the front end, you might do that with Axios. And by encapsulating it in an adapter, and that's a very good practice, especially for third-party libraries, if you use them. By encapsulating them in this adapter, we can then use them in our application, in our Vue, for example, in React or in Vue itself. And we always just use the adapter. We use this class that we've written. And by doing that, we can easily go back to our adapter and replace and remove Axios and then do just pure fetch implementation. And we don't have to change anything in our Vue, in our React app, because this adapter is encapsulating the third-party logic. A second example is the block, it comes from Flutter architecture that's really focusing on streams and kind of event-driven development and state management. And it's made really for reactive and scalable apps. And it looks like this. Again, on the right side, you have a core kind of logic. You have a part that deals purely with data, with your repositories, with your APIs. You have a part that deals purely with your domain, your different entities, and the use cases of these entities. And then you have the presentation part that deals with the different events and the state. And then here, again, you see the view is separate. So the app is separate from the kind of business and the data logic. And this view separation is really important if you're growing over time, because it allows you to remove certain views and to remove certain parts of your application without touching the business logic or without touching the logic that goes to the API or the database. And yeah, this isolation and this separating, again, can be done with having packages and having different, more isolated parts in the application, with having multiple repositories. But generally, you should try to isolate these different parts of your application and separate the view from kind of your business core logic. So that's the 6 constraints, defining how parts of the applications are connected and isolated from each other. And yeah, let's move on to the development processes. So as you grow and as you get more and more developers, the development processes also become very important, because your team will spend a lot of time on writing code and adding new changes to your system. And there are some core parts like the demo environments, the CI configurations, but generally also the manual development process that you need to look at to make sure it's working and it's working in favor of your developers, so they're not hindered in adding new changes. On the front end, that means building a good CI environment. So I also worked a lot on the CI environments, where you have your different continuous integration pipelines of building, of running your unit tests, of running your integration tests, and then also the delivery pipeline, where you have the staging environments, you have the production environments that need to work together to finally deliver something. And you will spend a lot of time on these CI environments. I have one example here. This is just a code example of a GitHub action snippet from Metabase that you can also look at. And that's basically, it just sets up the front-end environment. It defines which Node.js version you're using. It defines if there is some caching that it could be reused, and how you install your Node modules. And in your CI environment, you need to create all these modular blocks so you can build good jobs that can work in favor of whatever your system is doing. And in the CI environments, you should really focus on removing any kind of manual tasks to give this time back to your developers. So you should run your tests in the CI environment. You can automatically create change logs based on the commits, for example. You can auto-format your files. You can report problems. So if you run your testing, you can have actual test reports under your PR or in a separate kind of testing tool. And spending time on the CI environment really pays off, because it gives time and minutes back to the developers who can focus on actually developing the logic instead of manually checking everything. The second parts are the demo environments. So generally, if you have many developers, you should have a deployment for each PR. So each PR should be deployed and be testable, and you should have a URL for each change you make and you want to merge into the code base. So you can send it to your designer, you can send it to your project manager, but you want each PR to be deployed and testable in a visual way to be very fast in this collaboration, and also to detect very fast these kind of surface error, these visual errors, and collaborate really well with your different people that work together with you and your team. And then automation, especially in development, as we write code, is very important, because we spend so much time on writing the actual code. So here you have an example of Plop, which is basically just a scaffolding tool you can use to scaffold, for example, testing files or component folders, or, I don't know, configuration files. And by adding these tools and making these manual tasks faster, you can save a lot of time. So one thing that's really good is GitHub Copilot, because it auto-completes your code very fast. So you don't have to type everything. It can infer kind of what you probably want to do. It really helps you develop faster, because you don't spend so much time typing. Another thing that's really important to automate is the project setup. So how long it takes to get your project actually running. If you have a good setup, it shouldn't take more than half a day or a day to actually have the whole system running on your machine. And mostly that's done with Dockerization. So in the beginning, most code bases, they wouldn't have like a Docker example of how that is set up. But the more you grow, the more you will also work on having these containers and having a fast spin-up of the whole system. And also the testing and the deployment that I already mentioned. So having these previews and having the tests running in a CI instead of your machine. And yeah, then you can create automatic scaffolding of good use cases that you want to enforce also within the code base. So maybe each component have a certain naming, or they should have the test files right along it. So by having these code generation tools, you kind of make it easier for the developers to not have to create everything by hand. So that's our constraint number 7, speeding up the development process, ensuring the file consistency, and enabling seamless collaboration, not only between the developers, but also the designers and product managers and all the people working with the system. And lastly, no, almost lastly, we will talk a little bit about migration, because I also worked on a lot of migration the past 4 years. And when we create a new project, I say it's very similar to a marketplace. You have a lot of options when you create a new application. especially on the front end. You can have a certain framework, maybe you have Vue, you have React, you have Svelte. Then you have some kind of testing, you have Playwright, you have Cypress, you have Jest, you have White Test. You have some kind of design option, Tailwind, SAS, PostCSS, any kind of design you need. You have some kind of build tools like Webpack, like Gulp, like White. And then you have some kind of state management like Xstate, Pinia. And then you also have some helper libraries like Storybook that help you document your components, or some things like Lodash that you will find in most projects. The important thing about that is it's not important to be so opinionated. You can build a really great front-end app with React or with Vue or even Svelte. All of these tools were perfectly fine for creating an application. But what's important is the end usability. So can your developers work with that framework? If you build your frameworks yourself, it's going to get hard for new developers to actually learn that framework. So the usability of the end product and also the developer experience of your developers are very important in choosing these libraries. And if you look at the state of JS, which is quite interesting, you see that over time, libraries gain a lot of popularity, they keep growing, but then after some years, they lose popularity. So that's all the pink kind of libraries here. And that's also what happened with Gulp, for example, which is a build tool. It was very popular and the most popular build tool on the front end for a long time. And then Webpack came along, which was a better choice and just could do more. And then it really, really dropped in popularity, and it was removed more and more from all the projects and replaced with Webpack. And that's what happens generally in our software systems. So the longer we work on a system, the harder it gets. And you have to work on migrations. You have to work on changing and removing parts because of security concerns. So really old codes, libraries that are not updated anymore, they normally have security problems. Because there's better alternatives like Gulp and Webpack, there's just new alternatives which can do things better and faster. There's new versions, so that's what I worked on a lot, from Vue 1 to Vue 2 to Vue 3. You have to update your framework to stay ahead and not have security problems. And also bad developer experience is a big reason. So if it gets really, really hard to add a single change into your code base, and if it's really outdated code, maybe it's not really properly building anymore because of a really old Node version, you also need to work on that migration. And it becomes really hard to make changes if you don't migrate. Yes. So that happens in any software system, that you need to do large-scale migrations and you need to work on these kind of migrations. And what I worked on a lot in the past 4 years on the system was replacing the language, moving from JavaScript more towards TypeScript, removing the build tool and moving more towards White because that fits a lot better with the Vue environment. Maybe you're removing the package manager, and you will not really get around that. You can not do it, but over time it will get really hard to work with the systems if you just refuse to do it. And there's a really good blog post from Will Larson, who also wrote three or four books around that kind of topic, that really talks about why migration matters. I will not go into too much detail because my time is almost over. But essentially, engineers and managers, they really hate technical debt. They do want to reduce it. They don't do it on purpose to add this technical debt. And as a system grows, there is more and more technical debt naturally occurring. And to keep growing and to keep the system alive, it's essential to tackle that technical debt and make migration plans. And if you get to a mid-sized kind of company, there is this phrase that says running to a standstill. So these companies, they're faced with so many migrations that they need to work on that they actually cannot really develop new features anymore because they're constantly just migrating things to keep it even running. And the problem there is really that migrations consume capacity and resources. And what Will Larson talks about in his blog post is really how we can make that plan and how good migrations plans are made together with your teams in different phases, where you have a discovery phase, then you have an enablement phase where you talk to your team and see how those teams can do the migrations together. And in these migration plans, there's really a lot of trial and error and talking, and it's not just a single person doing that migrations, but really a long-term plan that's iterated together with these development teams. So that's our constraint number 8, removing outdated tooling and frameworks through migration strategies with multiple teams. And we have the production processes, but I will not go too deeply into that. Basically, it talks a little bit about feature flags that are important if you want to deliver very fast and very continuously. In all the systems I worked on, we used feature flags to already ship code to production, even if the feature was not active. So enabling continuous and controlled releases with instant rollback is very important if you want to deliver in a fast and consistent way. Analytics are very important, so I've worked a lot with Segment, Google Analytics, Metabase, all these different kind of analytics tools that help you to track what's actually happening, to track where the users are. You can see a lot of like which are the most active routes, which are the events that happen the most. Sign-up tracking is very important to see which sign-ups happen, how many sign-ups happen, who is signing up. These are very important data points. And then you want to analyze that in some kind of data visualization, like Metabase, where you pull in all the data and see what's actually real-time happening in your system. And that's important because the architect also needs to make some decisions and prioritize certain things. And you should always make that based on your real-world data, on your analytics data that comes from Google Analytics, that comes from Segment, that comes from Posttalk. And then you can really get the buy-in if you present that data and show, well, this page might not really be working. We need to make the sign-up page differently. And monitoring performance, the previous talk was also talking a lot about logging, is also quite important. So you need error monitoring, for example, with Sentry. You need some way to monitor your distributed servers. So your different servers you need to monitor and see, well, are some endpoints slow? Is there a lot of errors happening on some backend area? So these systems are really important to make sure you're actually working on the areas that are affecting customers, that you're working on the slow endpoints, or you're fixing those bugs that are always crashing your front-end app. These are very, very important. And the later you go, the more you go towards scaling, the more you go towards product maturity, the more you need to work on reducing this depth and monitoring and making sure your system is stable. Testing I will not talk about too much now because I think a lot of you are familiar also with testing probably. But we need testing to allow systems to scale. And especially any kind of manual process. So if you have a person clicking through your application all the time to make sure it's still working with the change you're making, that's really something you should automate with testing, with Playwright or Cypress, and where you should invest time to write those integration and end-to-end tests. So to recap, the architects enables constraints to allow to scale and to allow to tackle technical debt. We need to define some visual architecture. We need to talk to our design teams, define our tokens, define the actual data values of that design. And at some point, you need some design systems, some core components that you can reference in all parts of your application. You need some code structure. You need to define how your commit messages are written, what ESLint rules are active, how your files are formatted. You need to make sure your developers can actually work in the system and develop properly. You want to take away all the manual tasks that they need to do and let them really focus on developing your core functionality. So have good CI processes, have good demo environments, and animate any kind of manual. I need to click and create a file that actually is always the same. The longer you work on systems, the more you will work on migrations. So there's, I don't think, a single system that runs over a few years that doesn't have to do any kind of migration. And there you really need to create migration plans with the different stakeholders and also with the different teams to make that migration happen. And in the tech stack, usability is always more important than if it's the newest, greatest thing. So you should really think and pick those things that work for the team and the organization. And then the production processes are very important for making the right decisions, looking at the real-world data, looking at where errors and issues are happening in your system to make sure you're also making the right technical decisions for that system and for that application and for the customers and the end user. Yeah, that's it. Thank you for listening. You can find some more on my website, and you can reach me on LinkedIn.
Thank you so much, Lisi. We do have... You first, me first?
I do have a little present for you, of course. You were talking about this little zoo that might fit in. That's an insect hotel, Neos branded. So one's for you.
Thank you.
And also a tea box.
Thank you.
And thank you very much for joining our Neos zoo here.
Thank you. It was nice to be here.
But we also have some questions. You talked about the architect in the beginning. Do you see one architect doing everything from the microservice server architecture to the front end, or would you rather split the workload, as it can become quite a huge technological range and scope? And if split, where would you split?
So, I mean, there's always higher architects. There's also architect teams. So it makes sense to have a front-end architect and maybe have a back-end architect and have these architect kind of teams. But as I mentioned, it really depends on the company size. So you have one architect for maybe 50 developers, maybe 100 developers. And it also depends on the definition that the company has for the architect. So if the architect is still involved in like technical things, if they're still coding. So it really depends a little bit different on how the definition of the architect in that company is. But generally, I would say it makes sense to split the load and have also for architects, have an architect team, if that's possible, where certain architects are more focused on their expertise. So maybe the front end or maybe the microservices.
Mm-hmm. Thank you. Next question is, do you have any suggestions for documentation tools for the front end? Because it would seem a good idea to have a good screenshot and video support.
Yeah, I mean, there's many tools today. So I worked a lot. It depends on also what you want to document. So if you want component documentation, Storybook is the most common one. But there's like framework-specific documentation tools, so certain tools for React and certain tools for Vue. I would say the people who actually write the documentation should make the choices because they also need to work with it. So you need to check also with your designers if they're writing design documentation, if that works. But yeah, I would say look at what the most common tools are within that framework environment, so the React environment or the Vue environment, because these tools, they can also render your components, and then it matters if you have a Vue component or a React component. And it's nice to have this interactivity and to actually be able to use and click through the component.
All right. Last question before we release everybody to lunch, and you. I'm hungry. How do you keep the design consistent for parts of your project that cannot share presentational components due to technical reasons? For example, when theming third-party products used in your project?
That's
a good question, apparently.
That's a good question, yeah. I think configurations like Tailwind try to do that, so to have a clear configuration system where maybe you have multiple projects and you have multiple customers, but if you decide within your company, this is kind of the configuration we have for design, that can be Tailwind, but it can also be other things. There's also a lot of plugins that go into Figma, for example, or that go into Sketch. But really defining this configuration level of the design can help you keep that more consistent across different projects and maybe also third-party projects.
All right. Thank you so much, Lisi, for your insights. Do we have another small, middle, large round of applause for Lisi in the room? Thank you.